this harmonic oscillator problem. Okay, so let's go for it. So I'm going to rewrite that solution that we've got to solve here. So I put it up here. Second derivative in y. And again, we'll address this transformation of coordinates soon. I don't want you to be too worried about it. For now, it just helps us kind of ease through the solution. Okay. And so let's see here. If my guess is psi of y equals f of y e to the negative y squared divided by 2, then this starts to become a mess, and I'll show you. So now, did I leave myself enough room? Yes, I got enough room. So first thing I need to do is take the first derivative of this, right? So I'll say d dy of psi of y. And look, you can tell that I'm going to have a chain rule situation, right? So first I take the derivative of the function. That's going to be f prime of y. And then times the other part of the function. And then now I've got to take the derivative of the exponential. And so that's going to be, it ends up just being minus y, right? So it becomes minus 2y divided by 2. So that's just minus y times f of y times e to the negative squared, e to the negative y squared divided by 2. Okay, now as you might guess, we've got to take the second derivative of this thing, and it's going to get hairy. So I have to take the derivative of the derivative, right? And so what we're going to have, let's make sure that I keep track of all my things on my cheater notes here. So first thing I'm going to do, I'll take the derivative of this term. So that's going to give me the second derivative of that chunk times the original function, e to the negative y squared divided by 2. And then now I've got to do the derivative of the exponential, which is going to be negative 2y divided by 2, or just negative y. So that's going to become negative y times f prime of y times e to the negative y squared divided by 2. Okay, now I've got to do the derivative of that second term. Okay, so now I've got a triple situation to deal with, right? So I've got y, I've got f of y, and I've got e to the negative y squared divided by 2. All right, so the derivative of y is just 1. So now that whole chunk is going to become minus f of y e to the negative y squared divided by 2. Okay. Now we've got to do the derivative of the function. So that's going to be negative y times f prime of y times e to the negative y squared divided by 2. And then finally, I have to do the derivative of the exponential. And so keep in mind, I've already got a minus y there. And so the derivative of this e to the negative y divided by 2 is negative 2y divided by 2 times e to the negative y squared divided by 2. So that becomes negative y times negative y, which becomes positive y squared. And then now we just keep everything together, f of y, and then e to the negative y squared divided by 2. Goodness golly, so there is just our second derivative. And we could inspect this really quick to see if there's anything that I can cancel or combine. So let's do that really quick. So here is, yep, 2 terms that I can combine right there. So that's nice. And then what else can I combine? Let's see here. Okay, so let's keep track of this. Let's keep this going. So I'm going to say now all of this equals. And then another thing that I'm going to do, you can tell right away that I can factor out an e to the negative y squared divided by 2 out of all of these terms. So I'm just going to do that straight off the bat. Okay. So then I would have my second derivative, right? Okay, times the exponential. And then now, so I can combine these two things, negative y, f prime of y e to negative y squared, And that's just going to become negative 2y times f prime of y. And then I've got the exponential right there. So let's see. So then now I've got to deal with this f of y right here. So I'm going to cross these off so I know that I've dealt with them. Okay, so I've done all three of these. So now I've got that term, and so that's just going to be minus our function in y. Okay, and then so I took care of that. And then finally, we've got to take care of that, which is now going to be plus y squared times f of y. And so I'll remind you, right, this is just the second derivative inside. That's all we've done. We haven't even put it through our Schrödinger equation yet. Oh, man. Okay, so let's do that. So when we do that, we get the following. So we've already got the second derivative, so there it is, right? So I'm just going to rewrite all of that as the following. I'm going to say, let's see. Oh, you know what? Do I have a whole nother page to deal with? I got a whole nother page to deal with. So great. So let's do that. Okie dokie. And I'll just remind you up here once again, our Schrödinger equation that we're trying to solve, minus y squared, or excuse me, this is really just our, the reduced form plus y psi of y equals 0. Okay. So let's keep it going. So our second derivative of psi, that was the big function, where that's going to be f double prime of y minus 2y f prime of y minus f of y. I skipped writing a term. So this will just be slightly out of order than the previous slide, but that's okay. So those are the two terms I wrote out of order. So then now that's all times e to the y squared divided by 2. Okay, so just this is our second derivative, right? Now we've got to say minus y squared times our psi of y. And remember, our psi of y, we guessed that it was some function f of y e to the negative y squared divided by 2. Alrighty, so that's now y squared times f of y e to the negative y squared divided by 2. So that takes care of this middle term. And then now finally, that's plus lambda times f of y times e to the negative y squared divided by 2, all equal to 0. And so let's see here. Is there anything we can do to simplify this? So we inspect once again. And oops, I forgot to put, so I'm going to make some much bigger parentheses around this thing, right? So remember, this is e to the negative y squared times this whole chunk, okay? And so if we look at anything that we can cancel, yes, brilliant. Look at this. I've got the y squared and the y squared terms, and those will cancel out. So that's great. So now I can say f double prime of y minus 2y f prime of y minus f of y, and all of that is still multiplied by e to the negative y squared divided by 2. And so now that chunk goes away. So then now this is just plus lambda f of y e to the negative y squared divided by 2. And this is something, reasonably we can work with, right? As you can tell, if we keep going with this thing, I could even cancel the e to the y squared divided by 2, okay? So we can cancel those out, and we can keep simplifying. F double prime y minus 2y f prime of y minus f of y plus lambda f of y. And then now to simplify this even further, we can combine terms with the f of y. Okay, and so that's going to get combined as lambda minus 1 times f of y, so there's a plus there, all equal to 0. And now we still haven't solved the thing, but we've got it in a much more reasonable form. Okay, so we have, right, let's just kind of go through this again, and I'm going to box this off. So it's still not solved yet. All right, so what do we got to do to solve it? Well, we recognize that we need some function, some polynomial, second derivative of that function. We need then obviously the first derivative of that function and then just the function. And it has to satisfy this relationship. Okay. So the general solution of this, we know that f of y has to be a polynomial. So our general solution for that polynomial, I'm just going to set this up as the general form of a polynomial, which says the sum of all terms a y to the power nu, where nu is going to be my polymeric term that I can keep adding on. So for example, if nu is equal to 2, then I would have some polynomial that says, you know, a y squared plus a y plus a, right? Or if nu is equal to 4, you know, I would have y to the 4th power plus y to the 3rd power plus y to the 2nd power, etc. So I would get these polynomials.